to start this lesson, I'd like you to start by evaluating this expression. It's a big, crazy looking expression, but if you focus on your order of operations, you can work this through. So order of operations, remember, PEMDAS is how most people remember it. First do the stuff inside the parentheses. In this case, that means the stuff inside of the square root. And then you're going to do any exponents. Well, there is an exponent here, so you're going to have to do that before anything else on the inside of that square root. Then you do the multiplication and the division. Once you've done the multiplication and division, then you take care of any addition and subtraction at the end. So go ahead and evaluate this. That is, do all of the calculating and figure out what it is as a decimal, and then round your answer to the nearest hundredth. Once you've worked it out, then go ahead and proceed so we can start checking our answers. So the first thing I do is I do the stuff inside of the square root. So that's the 7 squared, and I do that multiplication. And I also did this multiplication on the bottom because none of those went ahead of any of the others. Now I need to do the stuff inside the square root here of doing the 49 minus the negative 40. Minus the negative, remember, becomes plus a positive. Now that I have it down to this is as much as I can do without plugging it into the calculator and going into the decimals. So on your calculator, you're now going to do negative 7 plus the square root of 89. Get that number and then divide it by the negative 4. If all goes well on your calculator, you should be able to get negative 0.61. Before you proceed in this lesson, make sure you can get that number. Now we're going to be coming back to that type of a problem here in a minute, but first I want to pick up from what we've been doing recently, which is solving quadratics and polynomials. So to start with today, write down and solve this first problem. Do that on your own, and then we'll come back together and actually check it here together to make sure that you're doing it correctly. So resume the video once you've done that. All right, so how do we solve that one by factoring? We first factor by saying what adds to 15 and multiplies to 56. That's going to be x plus 7 and x plus 8. Now that we have that, we set each of those equal to 0. So we go x plus 7 equals 0, which means subtracting the 7 from both sides. So we got x equals negative 7. Then we do the same thing with the x plus 8 equals 0. And so we subtract 8 from both sides. So you got x equals negative 8. So in this problem, x equaled both negative 7 and negative 8. You might be taking it for granted right now, but notice that whenever we solve one of these quadratics, it gives us 2 answers. That's going to be coming up again here in a minute. All right, now let's take a look at the second one. We need to solve this. And we solve them by factoring. But this one is not too pretty for factoring because, first of all, there's nothing that adds to 7 and multiplies to 5. But even beyond that, this negative 2 sitting out front actually means that that technique doesn't work the same way. It would actually create much greater complexity in it. And so in this lesson, we're introducing a new way to solve something that looks like that. In other words, something that we could not factor. You're going to want to add this into your notes because you're going to be looking back at this and using it here for the next few days. This is called the quadratic formula. You notice basically the problem that I had you do at the start of the lesson, it was evaluating this quadratic formula. It's just there were numbers plugged in instead of the a, b, and c. We're actually going to be doing that here together here in a minute. But first, write down these notes, and then we're going to go and actually put it into practice. All right, so now that you have that in your notes, we're going to go back to that same problem, and we're going to see how to solve it using the quadratic formula. So first up, what I want to do is I want to figure out what do a, b, and c represent. A is always whatever number is multiplied by the x squared. So in this case, my a is going to be negative 2. B is whatever number is multiplied by the x. In this case, that's going to be a positive 7. And c? C is whatever the number is that's hanging on the end, that has no x or x squared with it. So in this case, c is going to be 5. Once I know that, I now plug that into my quadratic formula down here for a, b, and c. So when we plug in for a, b, and c, this is what we're looking at. Now notice that problem that I had you do at the start of class is the exact same thing as what we see here, except for one little variation. You notice here this has this plus or minus symbol in it. And that's how we read it. We read it as plus or minus. The reason is because what it tells us is that we're going to do the problem, and we're going to do it once where we treat that as a plus, and we're going to do it once where we treat it as a minus. So we actually already did the calculation where you did it as a plus. So just like we saw before, we go ahead and we use the order of operation, and then we get it down to this part here where we can do the calculation in our calculator. But the plus or minus tells us do it once with the plus. We already know what that gives us. That's the problem we did at the start of class. That gave us a negative 0.61. And we also do it with the negative in there. So you can see down here, the minus, we do the same thing that we did before, except instead of adding the negative 7 in the square root of 89, that decimal that you get on your calculator, you're subtracting them. When you do that, you should be getting 4.11. Again, make sure you can get that number. And then that's the end of this lesson. From here, it's just going to be a matter of using the same formula. Now remember, we use the quadratic formula anytime it cannot be factored. Now you could also use this for other factorable ones, but it's a lot more work than you need to do. So if it can be factored, factor it. If it cannot, then use quadratic formula to solve it from there. And then if you want to see how more problems like this are done, a sheet of examples is also available with this lesson.